The reagents are basically giving out what it is. The copper is not appearing a lot in organic reactions, especially the alkyl halide. You treat the lithiums, that takes organolithium first, that exchange the halogen with the lithium. That's something called organolithiums. And then that is what you treated with the cuprous iodide. That's what makes the Gilman reagents, or the dialkylcuprate, in the case of isopentyl cuprate. That is a new completely carbon reacting with alkyl halide. So what dialkylcuprate does with the alkyl halide, they just make a carbon-carbon bond. We call it coupling reactions. So these carbon, which means that this carbon that bound to copper, that's the one that reacting with this carbon bound with the halogens. You got to recognize which carbons have come together, right? It's not this carbon, it's not that carbon, not this one, not this one, this carbon. That's the one that makes a bond with that carbon. That's the common mistake sometimes people do, not recognizing which two carbons are bound together in the end, right? The carbon bound with the copper, that's the one that bound with the carbon that bearing the halogens. So those two is going to come together. So this is that part, that side, this one, just put it together. Simple. Sounds very magical, and it is magical. This reaction does work well. So that's why when you want to make the carbon blowing it out, we use these reactions strategically when you want to make a carbon-carbon bonds. So that's how, what's this dialkylcuprate is known for, is famous for making these carbon-carbon bond formation reactions. All right, let's talk about how you're going to make these things. This is something that I want you to start thinking about. This is a final molecule, you want to make it, you want to start from there, then how do you do it? You got all the tools available in organic chemistry, how are you going to use them? In what way? In what sequence? So planning things out. It's kind of a testing how much you understand organic chemistry for all the organic reactions. So, this type of question is going to be appearing more now. And we did a little bit in the test too, very simplified manner, because we didn't talk about too many reactions. But now we are doing it, and then OChem 2, we are doing more. So this is something you got to use. Okay. These type of question, there might be more than one correct answer. Because if you want to make it, let's say you want to make a doghouse. How are you going to make it? First of all, you're going to get the plank of wood, right? And then you have to cut it out. But how are you going to put it together? You're going to put the roof first, or you're going to put the wall first? It doesn't matter which way you make it. Eventually, when you make it, right? So that's the thing. You want to make something. How you're going to make it depends on what you prefer. But sometimes one makes it better than the other. Normally, you don't make a roof first, right? You normally start, build the wall, then you put the roof. Or maybe roof prepared and then you put it on top of it. So there's so many different ways to do it. So this type of question, of course, answer key just shows only one of them, but there might be multiple right answers. And then we recognize good answers. So we give out credit for those things. So how are you going to do these things? So that's the kind of things now I'm asking you in this question. Let's talk about solving. You see here, alkyl chain is replacing the halogens. So you probably have to search your databases. Do I know any reaction, halogens replaced by the carbon chain? And some of you may think that, SN2 reaction. But SN2 reaction is not a good reaction because that's a halogen on benzene. We don't see that happen with those type of alkyl halide. These are aerial halide, benzyl halide. That's not very halide. So this is not going to work. So you should think about some other reactions. The good thing is that you have a very fresh memory of the dialkylcuprate. That's what it does well. You can have the treat the lithium make the bromine replaced by the lithium, you make organic lithium there. And then you treat the cuprous iodide, you make a dialkylcuprate. And then now you need the alkyl halide of this part, which is a dark molecule with a halogen bound to it. Then these two will come together and make a bond. So that's very easy reactions. If you remember dialkylcuprate, that's the right answer. But is this the only answer? Then no, there's another one. How would you do it? Some of you may think that, okay, then I'll just make a greener. So magnesiums, you add it to this, you make a greener. This one attacking that SN2, that is what I've been saying, doesn't work well with a greener, unfortunately. So that doesn't go. One other possible way, if you have this one, that also pretty strong nucleophile there, it also is a good base. That attack this and pick it up by SN2. I think it's possible because it is a primary alkyl halide. So in a strong base like this, you need to worry about E2 elimination reactions, but E2 elimination doesn't go well with the primary alkyl halide. So if you mix this with that, then I'm pretty sure that most likely you will get this. So that might be the right answer as well. But I think for this way, because if you go this way, there's no elimination reaction at all. So it's much more well-controlled reactions. Grignard is a bad choice because even though that's nucleophilic, it doesn't work well with an alkyl halide, unfortunately. So that's what we're going to do that. That does not mean that Grignards never going to be useful. You still can do it with a Grignard. So how would you use the Grignard to make this thing happen? You just have to think out of the box, or start using the reaction that you know in a little different way. So this is what makes it challenging or interesting at the same time. What I suggest, not this, you can use an aldehyde versions of that. So same skeleton, we got same carbon, 5 carbon, 1, 2, 3, 4, 5, right? Except the alkyl halide, we mix it carbonyl. That's a Grignard can react with. Grignard is going to make an attack, you're going to get an alcohol, not this, you're going to get an alcohol. So it looks like we are getting wrong way. But the thing is, if you can remove the alcohol, then it becomes a product. So the question is, how are we going to get rid of an OH? Erase it, right? You just have to clean it up. Unfortunately, there's no way. You cannot simply get rid of OH alone. You got to remove other things with it. So OH, how do you get rid of an OH? You should remember, if you treat a strong acid, that will be protonated, that's going to go. E1 elimination reaction, you get a double bonds. OH is gone, but you get a double bonds. But reducing double bond to single bonds is much easier. That's a simple hydrogenation reaction. You are adding hydrogen gas with the palladium, then you make a single bonds. So that's a different way of making the same thing. If you propose this way, would I deduct any points? No, it's a fairly valid reaction. Nothing wrong there. All goes well. There's another right answer.